standard है ना, we have to take the data or the 3D CAD data from the company, है ना. They will so basically I don't think you will get the complete 3D data free from the website, है ना. तो we sometimes we have to,
order or quotation.
yeah, we have to order, yeah. So they will provide that data. See here. So this is the component, right? Two cavity component. For example, okay, there was a noise.
No.
Okay, see, okay, so here you can see that this is the two component. So apart from the cold runner mold, we have to prepare the hot runner mold for these two components. So basically, where will be the location? For example, where will be the location? So we have decided that from this point to this point, we have decided that this is the location. This is the first location. This is the second location, right? And both the component are the same. Depending upon that, we have selected this. See, so this is the cavity section. This is the cavity section. See, see. See, right? See, so as I told you, depending upon the component geometry, this is very important. See, we have a limit here. We have a distance here, है ना? For example, if we have not distance here. For example, we have only 5 mm here from this point to this point. So basically, we have to take the distance type of nozzle, right? Which provide the distance from one feature to another feature, right?
Yes, sir.
है ना? Now see here, this is the all the, है ना? तो this is the replica of that nozzle, है ना? This is the replica of that nozzle. Now see, this is the nozzle and the manifold both. See.
But this thing, I mean, in hot runner,
Yes.
you will not have a main runner or the branch runner. Directly, you will insert the material on the gate.
Yeah, but here basically I have designed the complete hot runner with the nozzle, है ना? So we have all, yeah. So here you can see that. So basically all the internal part is not here right now.
Sure. Okay, sir.
Now see here, for example, see, this is the manifold, है ना?
Manifold.
What is the purpose of this channel?
Just a moment. Which one, sir?
Yes, this one. See.
Yeah, electrical conductivity.
Yes, है ना? Or here you can see that this is the one more component. This is simple type of hot runner system.
That is fine, sir.
Simple type of hot runner system. Now, I'm showing you one more hot runner system. You will see here. This is the quite complex, na? Depending upon the component geometry. See what type of hot runner we are using here. See, this is the position for the hot runner. See, single side hot runner. See, right? This is not a double sided, है ना? Or now see here. See, है ना? This is the cooling. See,
Cooling line.
है ना? This is the cooling lines, है ना? Now see. So as I told you, customer required edge cutting system. So that's why we have to provide the
nozzle directly to the runner to the gate, and edge gate or fan gate, whatever you want.
Fan gate or the tap gate we can use there, है ना? Now you can see here.
We can. I mean, hot runner is applicable for all types of gate. There is no constraint like a diaphragm cannot be used, or like a disc gate cannot be used, or like a pinpoint gate cannot be used. Something. It's not like that, master.
Yeah. Now, depending upon that requirement, what is the requirement of the component? Depending upon that, we have to use the hot runner system. For example, it is not. For example, with the hot runner system, we can use the disc gating system also, right? As we know about the pinpoint gating system, mid of the disc gate, right?
Yes.
So we can use that also.
Okay.
So as I told you, depending upon the component requirement, what is the component requirement, right? Now, this is the critical component. So basically, customer don't want nozzle point at this position, right?
Yes, sir.
So that's why we provide like this. See, this is the 1, 2, and 3. So this hot runner and the manifold, this is the complete selection procedure. But apart from this a hot runner or the, see here, what is this? This is this, what is the red portion?
Just a moment, sir.
Coil, है ना, coil.
Heater technology.
Yeah, coil.
Fine. Copper or like, I mean,
It is like a nichrome or something, right?
okay.
Yeah.
Nichrome, nickel chromium.
Yeah. So like a heater which is using for the heater also, right? So,
Okay.
yeah, they see here like this. Not the same material nichrome, but similar like the nichrome.
Okay. Somewhere some high resistant electric material, I mean,
Yeah.
wire for the heater.
Yeah, but maybe some other material, no, not the nichrome, that, right? Nichrome is a cheap material, you
No,
can say that, which is used
actually,
for.
I have brought some of my heaters for my company.
Yeah.
Tube type heaters, cartridge type heaters. So there may be like band heaters or like plate heaters. Yeah. Brain stream heaters also will be there.
So what is the material used for that thing?
They use SS actually for the tube type heaters.
Okay.
SS316L they use actually.
Okay.
But the SS will only conclude up to 200 or 250. Here we
Okay.
need at least 400 to 500, I think so.
Okay.
Higher, if you want to go for higher, as you said, nickel chromium or like something near to copper, because copper has a exceptionally thermal conductivity.
Yeah. So something near to copper material can be used there,
Copper
right?
material, if you use only, it will resist for 1000 degrees Celsius also.
Okay. So here you can see that this is the complete mold is similar to the hot runner mold, but here you can see that we are using hot runner instead of the cold runner, right?
Cold runner, yes.
है ना? Now see here, this is the slider here, this is a slider, this is one more slider, this is one more slider, है ना? Which is used for preparing the undercut into the component, है ना? And this is the complete hot runner system which we are using with the insert. See, this is the insert. See, this is the insert.
Slider
Cover
that I
out-
can say.
yes.
External undercut those.
Yes. See here. Right? This is the similar mold, but in this mold we are using the hot runner system, right? Okay, so you have prepared something. Acha, you have I have given you a taste or something before few lectures.
No, sir. You told me to practice that one. I have practiced it. I showed you. You said some correction. I have updated it.
No, taste means theory or the calculation questions. I have given you or not?
No, sir.
No? Okay, so today I am giving you some few taste number 1, which is very important, right? And you just write the answer of that question in your own words. Don't use internet for that. Okay, so basically it is like a test for the knowledge regarding the mold design, that what you learn from the course, right?
Sure, sir.
है ना? So today I will provide you that. अच्छा, you can show me your design practice if you have completed the you have completed the single cavity, right? And you have
Yes.
corrected that.
Yes, sir.
Yeah, you can show me.
Okay, sir. Sir, can you see my screen, sir?
Yeah. Is it visible?
Last time I did not include the ejector plating and spacing, sir.
Okay.
This time I've included it, but when I was doing, I had few doubts, sir. Let me ask those things.
Okay.
So I have just mounted all these bolts and all. I've checked it whether what is happening. And last time this core cavity separately, this one I did a mistake. You corrected me.
Yeah.
And this time I have done the correction properly.
Okay.
So those things I have done it. And locating rings, guide bush, guide pillar, those things and all I've had. Sir, one question is, when I was doing this one only, I mean, like when I was working, I got into it. How do you select how many return pins and how many support pillars you want, sir? First of all, if you say I have done this for this work, right?
Okay.
So this one based on your design size, I have calculated all these things.
Okay.
So this approximately this is 260 across somewhere like 210.
Okay.
How do I calculate? Like I know I should put here return pin as well as I need to put spring here.
Yeah.
How many return pin I should take? 4 or 6? Whether it depends upon part or weight of the mold, or like can I use larger return pins with less number of quantity, or like smaller 12 dia, 16 dia return pins with more 3 or 6? How do I evaluate that, sir?
Basically, generally, if I'm talking about it is all about the calculation. For example, what is the purpose of the return pin? It is purpose to retract the eject the to ejector plate and ejector back plate, right?
Yes, sir.
And this is the main purpose of it. So depending upon that load of these two plates, we have to calculate the return pin diameter, right?
Okay, sir.
Return pin diameter. But as we discuss about the guide pillar and the guide bush calculation, so we found the diameter for the guide pillar, right?
Yeah, we use a formula 4 root of 4 n
Yeah.
divided by those
So
fs value.
depending upon that, for example, if we found the diameter about for the guide pillar, we found the 22 diameter. So for 10 to 15% we can take for the which is thumb rule. 10 to 15% less than of that diameter we can take for the return pin.
Okay, sir.
Yeah, so this is the thumb rule, है ना? तो there is no requirement for separate calculation for that.
Okay.
Because the calculation area will become very you can say that complex, right?
Okay, sir.
So that's why. So basically, as I told you, all the calculation is depending upon the load or how number of components we are using there, right? Depending upon that, we have to calculate. But we should take the calculation. You can say that less calculation we should apply there, right? So we can use thumb rule somewhere if we are using there, right?
Okay. Sir, regarding this, I mean, last time we studied about those tipper plates and all those things and all. I understood, sir.
Okay. So here one more thing is that here your core insert, है ना? Your core insert. Why your core insert inside the housing?
No, sir, it's 0.5 mm offset, sir, actually on that with respect to the top.
Yeah, this is the 0.7 offset. But if I'm talking about the cavity insert, so cavity insert will be
Offset.
will be see here. So basically, this should be drafted into the outer area. See, for example, if you are making like this, so there should be a draft there, right? Where outer face of the side face of the insert.
Okay, sir.
There should be a draft. Minimum 3 degree to 4 degree. We have to give the draft, right?
I mean here. Or
Yeah,
here?
no. Yeah, this one.
This one.
No, this one. This blue portion. This blue face.
Okay, sir.
This draft is very important if you are making the insert like this, right?
Okay, sir. Maybe okay.
Yeah. So because it is right now 90 degree, right?
Yes.
So because of that, maybe possible that it can be touch with the face of that housing. Right?
Okay, so maybe it might be like sliding, and I mean it might be going.
Yes.
So this area should be completely drafted. everything.
Draft.
Okay, sir. Okay, sir. And that I'll look into it. Sir, another question.
Yes.
Now only I just got. How do you decide I mean, we know to calculate the number of cooling holes diameter based on part wall thickness.
Yes.
But I'm using here as a core and separate core insert and this thing. Core insert and separate plate for it, right?
No,
How do they provide
what you are
cooling to this
asking?
one, sir?
You are asking about the cooling or something?
Yeah, yes, sir. Cooling for this kind of insert type plate.
So which type of cooling we can use for this? You are asking this.
Yes. Because if you have one plate and you use it directly, like you have like through 8 dia for a 0 to 2 wall thickness or 10, you drill it and you connect the cooling holes on the other end using the tube and this thing. But my question is like this is a separate part. This is a separate part. How do you provide cooling from this part to that part? Like what kind of method we have to use?
From the top
The
we
top.
have to provide the vertical channel, right? And that
Ah.
vertical channel will be connected with the vertical channel of that core into the core inside,
Okay,
right?
sir. Okay.
And then vertical channel will become the horizontal line.
Yes.
Yes, so that horizontal will be continue, right?
Continue.
Yeah,
Okay.
so that is the
But
so that where will be the core housing and the core insert and the core housing will be made. We will use the o-ring there,
okay, sir.
right? So for the preventing the leakage.
Okay, sir.
Hmm.
So there, like you use, vertical with, the cooling channel will be like 90-degree with respect to the face.
Yes,
The
90
face
degree,
of the.
90 degree. Yes,
Yes, so with respect to this face, I can say it
yeah,
will be like somewhere around 90-degree.
yes.
So, should it be locked with something or like it will be open? Since I'm saying this, like there must, water might leak inside something. That will not, those things and all will not happen.
1 minute. May I show you 1 minute?
You show me.
I'm showing you that cooling 1 minute. Okay, just stop the
I'll
sharing,
stop it.
please.
Yes, sir, I'm doing it.
Okay, 1 minute. Multi cavity. I have see. I think I have cooling in this. You see here. Minute. This one. This is the cavity, and this is the cooling. See.
Yes, sir,
Right.
you're hiding.
So control J and just I'm transparenting, है ना? See here.
Yes, sir.
Understood? 1 minute. Let me control J. This is the see. Now it's visible.
Yes, sir.
है ना? Now see here, right? Okay. So this is the insert, right? And
Yes,
right
sir.
now it is going like this. See, from
Yes.
this point to
Point
this is,
coming
and this
inside.
horizontal will line become vertical here,
Yes.
right? है ना? Now again control G and take the face. 1 minute. And I am taking the another face. See. Okay. And control. See. So where will be the location for the o-ring? Here.
Actually, intermediate of that
Yes,
mating
yes.
part.
Yes, that there here will be the o-ring, right?
O-ring.
Yeah, because this is the way which I can use the o-ring there, right?
Yes, sir.
See, so this is the way, right? Of inline cooling or zigzag path for the cooling, है ना? Generally this type of cooling we use into the mold because this is the easy for the manufacturing, right?
Yes.
That's why this type of cooling we can use generally.
Okay.
है ना? Here as I told you, from like this, for example, this is the face of the component, like this, from the face of the component to the edge of this or the center of this cooling, right? So it will be the two-way, and again,
Two-way.
है ना? From
20 mm.
from this point to the again face of this will be the two-way, right?
Okay, sir.
है ना? And from one channel to another channel, है ना? 1.5 to 2A I can take, right? 1.5 to 2A I can take. From one channel to another channel, from the center to the center, right? Generally we will take 2A.
Okay, sir.
है ना? But here you can see that from this face to this center, we have to take again as a manufacturing feasibility or the 2A, right?
Yeah, sir.
This is very important, right? So this is simple type of cooling. Generally, this type of cooling
Yes, sir.
we should
No,
use
I have some
into the
doubt there.
household
That's what
product.
I asked. Like,
Yeah.
because if it is one single plate and we are doing the core cavity from the plate now, okay, I can directly drill the boring and I can find it out. But
Yes.
regarding the cooling, I have to see that.
Here one more thing is the core and cavity. See the core and cavity. So you are confusing. I think you are confused, quite confused with the core and cavity inside. See here. This is the, what is this? This is the
Just a moment, sir.
cavity inside, right? And see what is this? This is the
Core insert.
core insert. Now see core insert. See from this point to this point. This is the face here. See here, this is the interlock here. And this is not inside the housing.
Okay.
That's why you have to provide the draft here. But there is no requirement for the draft. There should be clearance between the core and cavity housing. See.
Just show show in the cut section, sir, like how you have placed it, and see that. Even I had the doubt. What I'm doing is right or wrong, but I was matching in the assembly and checking whether this thing, because
Your mold is right for the manufacturing process. It will be, and it will produce the component also, right?
Okay, sir.
But somehow you can say that it will increase the manufacturing costing, है ना?
Yes, sir.
Because you have to provide the initial this draft, right? So for making this draft, you have to apply the manufacturing costing also, right?
Yes, sir.
So that's why, or nothing.
Okay, sir.
Okay.
I understood, sir. Maybe that part I'll correct it, because it should not be in the undercut. Actually, it
Yeah.
should be coming out, right?
Okay, so this is the multi-cavity mold. So once you prepare the multi-cavity split mold, slider mold, है ना? So for the multi-cavity, I suggest you that you just prepare the multi-cavity layout. Okay, you just prepare the multi-cavity layout and show me, and you just design the slider mold. You start the design of a slider mold. So you will get lots of doubt there also, from there also, right?
Okay, sir.
Okay.
Okay.
So this was the today's lecture, okay, in which we have discussed about something about hot runner, okay.
Sir, this thing, one question, maybe I'm asking in
Yeah.
terms of preparing.
Yes.
Basically, hot runner, what is a hot runner cost will be, sir, in the market?